All right, hey everybody. This is just going to be a quick video here to sort of show you the basics of Mathematica. Um, I am pretty much referring to this page here. I have it up on my other monitor. I can put the link in Canvas later on, but I'm just going to kind of run through this sidebar here and show you everything that I think is important. So a lot of this stuff we'll be skipping, but I just want to give you an idea of like what is the most useful for our purposes. So the first thing is input, right? So I just wait for the little horizontal line there to blink, and I can start typing things. So the example that they have is 2 plus 4, right? So we'll just try that real quick. No, sorry, 2 plus 2 is what they have, but that's okay. So the first thing to note is that if I hit enter here, nothing happens, right? It doesn't spit back 4. So the reason for that is I have to hit shift, I have to hold down shift, then hit enter for it to recognize that I want it to evaluate something, right? So my input line is 1 here, my output line is 1. So this output corresponds to this input, right? And 2 plus 2 is as expected 4. Nothing shocking about that. Let's see here. So you can do basic, arithmetic and stuff just like you would be able to do on a calculator. For instance, I can, do multiplication. I can say, what is 2 times 2? So we use an asterisk for that. And then shift enter gives me 4, of course. And then for division, you're going to want to use the slash. I think it's forward slash. I can never remember which is backslash and which is forward slash, but it's the slash. You see it there on the screen. So I shift enter this, and it gives me 1. Right? These little suggestions here, for the time being, I would just pretty much ignore them. They are occasionally useful, but for right now, don't really pay any mind to that. And I guess to round it out, we'll just show you how to subtract. That's just 2 minus 2, right? And then I'm going to hit shift enter again. It gives me 0. Okay, so that's how you can do basic arithmetic with Mathematica. There are constants included in Mathematica, and this is something that is important to realize. So for instance, capital E, right, is not something we can use as a variable because it's I think you would say it's protected, and it's always going to be Euler's number in Mathematica, right, which is kind of unfortunate because sometimes we'll want to, for our purposes, use E to indicate energy or something like that, right? So we have to be mindful of the fact that this is already part of Mathematica's, how do I say this? It's protected and we can't change it. So if I, for instance, hit shift enter here with E, so it gives me this like sort of double struck E kind of, right? I'll try to zoom in a little bit more maybe so you can see it even better. And this is Euler's number, right? And so what I'll tell you is that, for instance, well, let me show you an example. I can do something like this, right? I can type in a fraction, and I can make a stacked fraction by holding down Control and then pressing the slash, right? So this is useful because this is sometimes a little bit easier to look at. And I can make Mathematica evaluate something like pi to the power of 6 over e, right? So to put pi in there, I don't want to type 3.14159.265, whatever it is, right, every time. I can just hit escape, and then you see these 3 short horizontal lines appearing. And then if I type in pi, I see a list of constants and stuff and symbols that are already inside Mathematica, and I just hit enter and I get pi, right? So I could do some things for Euler's number, which is that E. I could just put capital E, or I could also hit escape and then hit E, and then is it not included? Maybe that's weird. Maybe it's not included. What if I type no? Okay, so it's just capital E, right? So this is like me asking Mathematica, what is pi to the power of 6 divided by Euler's number, E, right? Which is normally a lowercase e. So I hit shift enter, and it's like, well, it's just pi to the power of 6 over e. You idiot, right? So And I think that I noticed that some of you were having this kind of issue with your calculator also, right? Like you have to tell Mathematica to make a numerical approximation. And the way that we do this, I'm going to show you two things here. The way that we do this is a capital N, right? So there's that. And every sort of function in Mathematica will use these square brackets, right? So this represents a numerical approximation, and then I put what I want Mathematica to evaluate inside. And so we'll see many more examples of this, but for instance, I could do a few things here. I could just retype it, right? I could do pi to the power of 6 over e, that would be fine. I could copy and paste this if I like the way that looks, and that's also good. Let me get rid of that. Or here's the fastest way to do this is I just put the percent symbol. Right now, percent means that this percent is going to be whatever is in your most recent output line, right? So for me, this percent would be pi to the power of 6 over e, right? So then I just have it evaluate this numerically for me, and it gives me a decimal approximation, right? So that's very useful. So again, to reiterate, whenever you use a percent, it takes the result from the previous line and manipulates that. So now I'm below output line 7, right? So just to show you again how this works, I could do percent times 1, and that should just give me the same number back, right? Because I'm just multiplying by 1, and I should get 353.675, and I do. So hopefully you see how that works. The percent thing is useful, it just saves you some time. Just looking through the little document here. It's saying things like, you know, Mathematica will obey the standard order of operations, which is great. I think that's pretty much the important stuff here. Maybe one more quick thing to show you is I already showed you that we can do a fraction, like a stacked fraction, by holding control and hitting slash, right? But I can also do like a nice power, let's say pi again. We want to do pi to the 6. So what I'm doing here is I'm holding control and then I'm pressing 6 on my keyboard, which is the little caret, right? The little up arrowhead looking thing. And then you can get a nice way of writing a power as opposed to writing this, which is the same thing, and it will give you the same number, but this is a little clunkier, right? So use the control key to get like stacked fractions and small powers. So escape, again, pi, I hold down control, I hit 6, gives me that, and then I can raise it to the 6th power if I want to. Okay, so that's all well and good. Here there's, like on this page, they're just giving some stuff about fractions and decimals, for instance. In particular, the one thing that might be useful for our purposes is there is a scientific form function. Okay, I can spell. Scientific form function, right? And so the example they give is, what if I have Mathematica put this number into scientific form for me? I shift enter, and it gives me 1.23 times 10 to the negative third, which is, you know, something that we will maybe do from time to time. We'll want to write things in terms of their multiples of powers of 10, right? Okay, there's that. Let's see here. Probably the next thing to do would be just to define a function. So we can show what that looks like. So I'm on line 10 now, right? Let's say I want to define a function. This is how I do that. I could call it f, right? I could call it g, I could call it h. I could call it anything I want, really, as long as I'm not trying to use one of those protected symbols that we were discussing earlier. So big E is a protected symbol, and big I is a protected symbol, so we can't use either of those. although before I talk about functions, let me just show you an interesting way of getting around that, right? So let's say I want to try to use capital E, but I can't because that's already understood to be Euler's number by Mathematica, right? This is what I do. I hit escape, and then I type a capital E, and then I just look for capital epsilon, right? Which looks very much like E, except I can do whatever I want with this, right? I could say, hey, Mathematica, I want to make this 10, right? And this is how you assign a value to a variable incidentally, right? I shift enter that, and now I could write like 2 times capital epsilon, and I get 20. Right, so there is a way around that, and the other one would be for I. I don't think we're ever really going to use the symbol I, but just so you see this, I could just go to capital iota, right? And this looks exactly like an I, so it's completely fine. So that's cool. Okay, anyway, so we were talking about functions. Let's define a function. I'll call it f. And let's just say it's a function of x. So if I want to define a function, what I'm trying to do here is I'm trying to come up with some operations that we are going to perform on a variable, and I want to streamline that process because maybe I'm going to be doing it multiple times, and I want Mathematica to do the legwork for me, right? So let's just look at an example of this, and hopefully it'll become clear. But I'm telling Mathematica, hey, I want to define a function, and I'm using the variable x, though it doesn't matter. I could use u, I could use y, I could use o. It really doesn't matter what you choose. And let's say this function is just 2 times x squared, right? So notice that I put the underscore after x, and that's how I tell Mathematica that this function is a function of x, right? And then I use this colon equals to define something, right? So I'm defining a function here. So I shift enter this, and now I can make Mathematica evaluate this for any number I want. I can tell it to tell me what f of 1 is, right? I can tell it to tell me what f of 2 is. I can tell it to tell me what f of pi is if I want, right? And it's just kind of an easy way to maybe use Mathematica to calculate a lot of different values of the same function. So there's that, and notice that basically Mathematica is taking whatever is in the square brackets here and just plugging it in for x. So if I do this, if I type f of u, maybe now, it's just going to give me back 2 times u squared. And now would be a good time to talk about like replacing something in Mathematica. And the way that we do this is with /. Right? So remember, this percent is just calling whatever is in output 16. So percent is taking the output from line 16 and putting it into line 17 here, the input for line 17. And now this /. is my way of telling Mathematica to replace something with something else, right? So this is what I do. I make curly braces, right? An open curly brace and a closed curly brace. And then I write, okay, I want you to tell me what u is, or what rather output 16 is, if u is, I don't know, 397 or something like that, right? So to make this arrow, I'll do this again just to show you. I just do a hyphen, and then I do the greater than symbol, and then it automatically converts it to an arrow. And I think we said 347 or something like that, right? And so that gives me this, which I'm assuming is correct. Now, in the event that you have multiple things that you want to plug in, we'll make another function. Let's call it g. We'll say that this is a function of both f and y. And we'll do a simple expression like, let's say this is x squared plus y squared. This is perfectly okay. I can make a function that accepts as many arguments as I want, right? This function f that I made accepts 1 argument. G that I'm making right now accepts 2. So I can do this, right? I've just defined the function so it doesn't spit anything back out at me. And now I could be like, well, tell me what g of u and v is if I wanted to do that. And so now it's just telling me u squared plus v squared, which is, of course, accurate. And what I can do now is I can make a substitution using percent again and slash dot, and I can tell it to evaluate this for, say, u is 5. And then if I want to make multiple substitutions, I just put them all inside the curly braces. But I have to separate each assignment by a comma, right? So I could say for v is 3. So notice that I put a comma here, right? That's how it knows to stop thinking about u and then to move on to thinking about v, right? So then this should be, what, 25 plus 9 is 34, right? And that's what we end up getting. Let's see. So, okay, it's been about 15 minutes. I don't want to make this video too long, so I'm just going to show you some algebra stuff, I think. And then maybe just limits and derivatives probably will be fine. Okay, so Mathematica can do algebra very quickly and accurately, right? So what I'm going to show you how to do is solve an algebraic equation, right? So one thing I could do, for instance, is I could have Mathematica solve this equation, let's say a times x cubed plus b times x squared plus c times x plus d being equal to 0, right? It has to be an equation for it to solve. And whenever you put an equation into Mathematica, you want to use this double equal sign. If you use one equal sign, it's going to complain to you. I can show you actually what it'll do. And I'm going to tell it to solve for x, right? So let's say I put one equal sign in, right? It gives me error messages. I don't know what these mean. I know that the bottom one says that this is not a quantified system of equations and inequalities, and that's kind of a sensible thing for it to say if it doesn't recognize this as an equation, right? So the way that I fix this is I just put in a double equal sign, and everything should be good. So I fix that. Now I shift enter this, and it's giving me this disgusting output, right? Because this is what you get when you try to solve a cubic equation, right? But notice how quickly it did it, right? It was not even like a second before it gave me this response. And so it's very powerful, right? This would be a very obnoxious equation to try to solve by hand. So Mathematica is definitely your friend. Now I want to also just show you how you could use this to solve a system of equations. So it's going to be a very similar process, except now I need to put in, let's say 2 equations and make it solve for 2 unknowns. So I'll just use this. I'll write a times x plus b times y equals c, and then I'll do d times x plus, remember I can't use e, so I have to use capital epsilon, times y equals f. So whenever you have it doing algebra for you and you need to solve multiple equations, you just separate them by a comma, right? So this is my first equation. I separate it by a comma from the second equation, and I include both those equations inside the curly braces. Then outside the curly braces, I put a comma. I put another set of curly braces, and I say, okay, I want you to solve for x and y. And then I remember to close everything with a square bracket, right? Now, this will give me what I expect, right? It's going to tell me that x is this and y is this. And this is correct. This is what you would get if you did it by hand, right? Now, there's this other function you can use that is really helpful, especially when Mathematica gives you, maybe a gross-looking expression, and this one is called full simplify, right? So I think that's a capital S, yeah. And as you've probably noticed by now, it will suggest, functions for you, and if you just click this, it inserts it, right? So let me try this again. So full simplify, and we'll see what happens if I take this result and plug it in. it cleans it up a little bit, right? So this is kind of nicer to look at, and it just does the algebra, the simplification for you. So this is a very useful feature of Mathematica here. Now, let me see here. Let me see what we have. We have plots. I'll show you just the very basics of a plot, and I'm going to use the exact example they use in the document here. So to make a plot, we write plot, and then remember that we always use these square brackets to have Mathematica evaluate something for us, or rather, to use a function that's included with Mathematica. And so I can put x squared plus 2 times x plus 1 in, so that's good. This is what it's going to plot for me right here. And then I just need to define the interval over which I'd like to see the plot. And they use x varies from -10 to +10. So this entry right here is telling Mathematica what, let's say what variable is being plotted. This gives you the minimum value that you want Mathematica to use, and this gives you the maximum value. So I have this looks good, I hit Shift Enter, gives me a nice pretty plot, right? This is definitely better than anything I could ever make by hand. And so that's also a useful thing. And you can plot, you know, like whatever you want, right? So there's that. I think that's probably it for this little subsection. I'm going to show you a few more things here, though, really quickly. I'm going to show you how you can use it to evaluate limits, right? Don't, you know, think this is a reason you can avoid doing your calc homework, but, you know, if you want to check a limit, for instance, you can use Mathematica. And so this is how we do that. We type limit. This is a recognized function. Always remember the square brackets. And let's say we want to evaluate this limit x cubed minus 1 over x minus 1. Well, this is where our function goes, right? We put a comma, and then we tell it the limit as x approaches what? In this case, let's say it's as x approaches 1. So then I Shift Enter this, and it gives me the answer, right? Just instantaneously. And this can even do limits at infinity, right? So let's also try this example they have. 2x cubed minus 1 over 5 times x cubed plus x minus 1. And now I just make x go to infinity. I type x, I type hyphen, greater than symbol, and then I'm going to use escape. I'm going to type INF. That shows me infinity, right? I can hit enter there, or just click it with my mouse, and now it's going to evaluate this infinite limit for me. And we get 2/5, which is undoubtedly correct. And maybe you can see that, right, because it's kind of like as you approach infinity, this subtraction of 1 up here and this addition of x minus 1 down here don't really have much of an effect. It's really just this 2 times x cubed over 5 times x cubed part that dominates. So that's cool. Hopefully you find that useful. And then I'm going to show you also how to do derivatives. This will probably be the last thing. So to take a derivative, right, and remember that Mathematica doesn't differentiate between, let's say, partial derivatives or ordinary derivatives. So there's only one function, and it's just capital D, like that, right? So in here, I put function, and then I put variable, right, like this. This is the format. So let's do something just horrible. Let's do like x to the power of 6 times ln. So in Mathematica, if you want to use ln, you actually type capital L O G, because it's understood that if we're taking a log, it's the natural log. For any other log, you have to specify the base. So let's do log of, I don't know, 1 over x, and then we'll do times sine of x or something like that. And you can use sine of x, you can use cosine of x, you can use tangent of x, right? These are all the trig functions that it understands. It would also understand, obviously, like secant of x, and cosecant of x, and pretty much any function, any mathematical function that is known, that is well known, right? It's gonna understand. So I can then just put x in here, right? And so now it knows that or that I want it to take the derivative of this function with respect to x. So we shift enter, gives me this horrible expression. We can see if this simplifies at all, so the way that we can do this is remember full simplify. And then I just put % in here, because remember that this is going to basically call whatever the output for the previous line was. I hit shift enter, and it cleans up a little bit, right? Like it factored for me and pulled out an x to the fifth, and then it combined some things inside parentheses. So, you know, sometimes things just don't simplify that well, right? But, okay, so hopefully you found this helpful. We'll definitely be working with this more. I just wanted to give you something to look at and hopefully help you get started with the software, okay? All right, I'll see you.